Welcome to another edition of the Sim Racing Garage. I'm Barry Rowland. In this episode, we'll be doing part 2 of a 3-part series of videos of the PT Actuator 5DOF motion system. Now, in this video, we'll be looking at the electronic components, the wiring, cabling, EMI shielding, and more. Time to put them through the SRG's review process and see how they do. So, let's get to it. Let's take a look at the servo driver box. There's going to be the interface between the servo motor and the rest of the system. Now, we need one of these for each one of our servo motors, or actuators, if you will. And I'll give you a look at the label on these. These are AASD 15As, and we'll be using that model number when we're in the SimTool software when we're doing our setup. And it also says it's a 220 volt, 50 to 60 hertz, and it will run 15 amps. Now, believe it or not, we're going to be running this at 115 volt northern voltage, just by making some changes to the parameters in there, because the motors used on these actuators can do that. How about that? Now, we also have another label or sticker up here that is PT Actuators sticker. I'm not sure if that's some kind of a serial number, so they know which one of these drivers went to where or how they're doing that, but there you go. And then we got some more stickers up here for the, let's turn this around, showing it's a 220 volt and some other numbers. And we also have probably the most important one that says rear right servo 4 on it. So each one of these boxes has a different sticker. Well, it has the same sticker, but different information on here. So it would be servo 3, servo 2, servo 1, and what the location of that servo is. And that's to keep us all organized when we're setting these things up and setting the system up. So it's nice that they actually do that, because they label the cables, and I'll show you that in a minute, for the right actuator also. So you keep everything in order that way. Now, on the front panel, we have a panel here that will show us the data and information we need to know, and also how we set the parameters within this box. And we will be setting those parameters. And once we get to that point, I'll show you how. It's pretty easy, but we're going to have to do 6 of them the same way. And we also have some plugs in here. We have the 25 pin plug that's actually going to communicate over to our controller, which is, here's the PT Actuator controller, and we'll look at this in detail later, but you can see the 25 pins on there, and 1, 2, 3, 4, 5, 6, actually 7 servos or drivers we can hook up to this thing. But that's the other piece. And each one of these boxes come with this cable, and it is a 25 pin cable, obviously, right? So it plugs into there and then plugs over here. Then we have another plug that's the data plug that communicates with the motor on the servo itself. And that will be in your harness over here that comes with your kit. Here's the other 15 pin plug here. So that plugs in there. Now, we also have some screw down lugs over here that we're going to be connecting things to. The 2 at the top, and we'll go over it in more detail when I'm actually doing it and showing you how I'm doing. The 2 at the top will be the power in, and we're going to daisy chain that between the different driver boxes. But we also have 3 on the bottom are going to be our power out to the servo motor itself. We've got some earth, you can see a little label there, earth ground screws here to screw down our earth plugs. Again, looks a little daunting, but it really not. Once you do one, it's just doing the same thing over and over again. Now, this box, as you can see, has a huge heatsink on it, and it's an aluminum heatsink, and we have this 60 watt high power resistor that's also in there. You can see the insulated cabling they have on that too. So they put it on the outside of the heatsink so it can dissipate heat also. So apparently these are going to be generating some heat. And we have some vents here, and we have some vents on the back. There we are, on both sides, and then over here. Now, I don't think there's a fan in here, but there may be. I just can't see it from here, but once we power it up, we'll know. So yeah, what else can we talk about in this box? I think that's about it. These are the mounting flanges for it, where we'll be mounting to our 2 40 series 40 profiles that we have over there on the base. And I want to show you the cable here that comes with, there's actually 6 of these. It comes with your kit. And of course, we already saw the 15 pin DIN. And it's neat because they've actually labeled these also to keep us straight when we're actually doing this. Let me get if I can get it to focus. There it is. And you can see this one says front left, and it's servo 2. So I wouldn't want to use this one for this box, because this is for the rear right servo 4. So you want to keep all this stuff together. And even they even go on the other side of it. Oh, wait a minute. While we're in the data section. This is the other side of the plug that goes to the driver, right? And this is the power. And this is how the servo motor is going to receive its power. Nice little spade connections there, and you can see the way they've tucked the wires in there when they crimped it. Well, let's get a focus camera. There we go. Well, this camera's not focusing as well as it usually does. And you can see there we have a ground and two powers. And actually, that's not a ground. That's another wire for going to the servo motor. This is the ground, okay? This is the yellow-green ground wire. And you can see it has a E on it for Earth. But it's not by itself. Look, there's another wire there. Haha. Another black wire that's going to be put onto the earth or ground lug. And what that means is this is actually a shielded cable for the power connection. Very cool. EMI, RFI is always an issue when we're running all these electronics, electric motors. We got servo drivers, a stack of those. It's always a concern, and it's nice to see that companies are starting to address that concern. I'm going to pull this, where's my 4? There it is. Pull this 4 lug apart here so you guys can see what they're doing here. There's actually a metal mesh that goes around the inside of this cable as it goes down, right? And they've gotten the ground wire in here, that black ground wire, that's not normal part of this cable. They just added it as they made the cables. Let's get these cable glands off. They just unscrew. And be very careful because we don't want to screw up our labels or anything. And I'm going to show you how they've done this. If my camera will focus nice for us. All right, so here's the yellow and green ground wire, the normal one. All right, see that there? But right next to it, you can see that copper wire. All right, so that's attached to the shielding that runs the length of the cable. And it's also attached to that ground wire. And again, I don't know how well you guys are going to be able to see this, but it's attached to the same pin in there that the yellow and green ground wire is. I don't know if you're going to see that or not. Anyway, that's the way the configuration is. So that runs the length of the cable and comes out here that we saw before. I don't mess up my driver. Let me just lay that down so it doesn't flop over on me. And here is the result of that. So now we've got the ground coming out of here. And again, it's part of the shielding there. So we're going to ground this on both sides. So that keeps the EMI and RFI down because of the way we're doing this. All right. So very cool that they've done this. It's something that I always request from manufacturers. I mean, you know, you're making it anyway. We got all this electronics. If you've ever tried to chase down a gremlin caused by EMI or the radio frequency interference generated by EMI, then you'll know what I'm talking about. It's not a pleasant thing, and this sticker is coming off. I guess I wasn't supposed to do that. That's all right. I'm used to it here at SRG. Doing things we're not supposed to. Tighten this back down, easy enough. And I'll keep my sticker. I still know this is the Servo 2, all right, which is the front left. Plus, if I get lost, I got another end over here I can read. And of course, you can see these are the cables that will be connecting to the actual actuator, or they come off the electric motor cables. And that's a 4-pin and a multi-pin for the data. All right, pretty easy there. Oh, I did want to show you this one thing. You'll get a set of these. I believe we get 5 or 6 of these. And this is our daisy chain cable, all right, for the power to these boxes. So in other words, the first box, and you'll see this when I'm wiring it, we'll get the mains coming in right here. All right, so we're going to have a hot, a neutral, and then an earth ground down there. But then I'm going to put these guys in there with that one, right? And also the ground with that one. And then we're going to take this and hook over to the next servo driver, the next box, in the same place. And then we have another cable that's going to do the same thing. The spades will sit on top of each other. We screw them down. So we're just basically looping the power coming in from the mains to all the boxes at once, and just using these cables, these handy dandy cables that they give us to do that with. And everything's nicely executed here, very professional. All the spades are nicely crimped, look like factory crimps. They're very well crimped. And yeah, so this is going to go together pretty easy. Again, when you're looking at it like this, it looks a little complicated, but it's really not. And I'll show you that once we start wiring them up. Now I'm going to attach all of my driver boxes to this 40 rail here. And what we're going to use, I'll show you the parts here, is this 5mm. Go here and get a focus on it. It's a 5mm socket head cap with a 4mm hex on it. And these are stainless steel units. We also have this lock nut, or not lock nut, but lock washer on there. And we also have that T-nut assembly that we've seen before. So the easiest way I found to do this is you just take these, and you see the flange there, it's got these slots in them, right? So it's not like a real hole and we can just put it in there. But we can just set these in here like this and make sure our lock washer is on top of it, right? And I'll turn that T-nut in there so it lines up with my channel. And then I'll get another one of these and do the same thing, just holding the box level, right? Try not to tilt it. And push these up against the edges here. Then I'll grab the other side and do the same thing. Slide it in there. Try not to jiggle it too much so the ones on the other side that I just did don't come off. And just kind of push them next to each other like that. Get my T-nuts kind of lined up in a straight line. And then it's just a matter of just setting it carefully into the channels. And hopefully, well, that one came off. We'll try it again. Patience is a virtue here, guys. Really not as difficult as it looks. Just got to be careful when you set it in there. this one doesn't want to do right, does it? So one more time, guys. In fact, I'm going to hold him so he doesn't go anywhere. So, the rest of the guys look like they'll go ahead and go into the slot. And if you're going in slot one gets crooked, I go ahead and rest one edge down that was successful. And just twist the other ones around a little bit. And this should drop right in like that. And there we go. So now all we have to do, obviously, is come in with our 4mm and tighten everybody down, right? And it'll lock in the channel like it's supposed to. So that's the easiest way I found to do this. And yeah, so I just have 5 more of these I've got to do over here in the row. And of course, I'm going to push this guy over next to him so we can keep them together. And the box that we're going to put them under or over the top of them fits properly. So yeah, I'm going to go ahead and get them all attached, and when we come back, we'll see how that looks. So here are the servo drives mounted, and I haven't finished spacing them out, so they're not securely fixed yet. But the reason I'm waiting is I'm actually doing a little fine tuning here. We want as much room as possible between these heat sinks of each drive so that they can do their job and keep things nice and cool. And I have this lid over here, or the side panel, for the metal box we're going to be actually building. And I'm using that as a template to see how far I can go on the sides here without interfering with the screws that are going to go into the side of that panel. And we'll talk about that more when I'm actually building it. So I'm almost there. And again, I want to get equal spacing between each one of these before we start wiring them up and doing other things. So yeah, we have them all installed now, looking good. We've got our bracket for our traction loss actuator on there. We're not going to install that for a while yet. And of course over here, we have our bearing pivot point pin, if you will, that's going to receive the bearing once we have that mounted on the chassis that we're getting ready to start building. So yeah, everything is coming along pretty good now. And yeah, let's get to the next segment. So now we're going to wire up the power for our servo drives. And I thought this would be a good time to do it while there's nothing else around here, and it gives me plenty of room to get to all of the connections I need to get to. And of course, you could do it otherwise, any way you want to, but I just thought this would be a good chance to do it. Now, I have a 3-prong, and you guys may have seen this before earlier, a 3-prong 110 or 115 volt North American type plug, and we have 3 wires that had the spade connectors, a red, blue, and a yellow, green, which is earth. And we're going to hook that into our first servo motor over here, our servo driver, not motor. And then we're going to daisy chain that power over to the other servos in sequence. And PT Actuator gives you a cable here just for that. And they give us 5 of them, right? And they're kind of nice. They have this loom material on them. And of course, they are color coded exactly the same as our power lead over here. So yeah, we have the yellow for earth ground, and we have the blue and the red. Now this is pretty straightforward the way we're going to do this. It's really not tricky at all. Anybody can do this. Just take your time. And yeah, I don't see how you could get this wrong. I am going to be using for the mains, we have 3 connections on each one of these drives. And we have an L1, we have an L2. All right, so L1 is hot, L2 is supposed to be neutral. And then down here, we have the ground, or earth ground, that we're going to be connecting to. So here's the way I'm going to do it. And it seems to work, so we'll go ahead and hook this up. I'm going to put the red wire on the L1 terminal for hot, and the blue wire will go on the L2 terminal for neutral. Now, while I have them sitting there, and this is really the only tricky part, and it's not too bad if you flip the wires around the right way, then the blue wire is a little bit longer than the red wire, and it will kind of fit in there and still curve around the back of these drives. That's how I'm going to have one here, here, and here, and that way they'll be out of the way. So we're going to see how all this works out. And yeah, this can be what I would call just a little bit fiddly, but it's not too bad. Just have to take your time with it. Put that red on top of the red and the blue on top of the blue, hopefully at the same time. And you want to make sure that these compression sections here, that they call these a compression type of fitting for the wires, you want to make sure they're all the way up so that you can get both of these spade pieces underneath that without too much trouble. And there's the reds. I got those done. So I'm going to get my screwdriver, obviously, and go ahead and secure the reds. And you want to screw this down firmly, but not a lot of torque, because it doesn't take a lot of torque to hold these wires. But just make sure it's down nice and tight, okay? And I'm going to go over to the blue one, and it kind of turned on me a little bit, it looks like, so it didn't go under. Now it's going under, all right? So I'll go ahead and turn that one. And again, just get a good tightness on it. You don't want to strip this. You strip this, you're in big trouble. Then we're going to put the neutral, or rather not the neutral, but the ground, the yellow and green, over here on the first ground screw, because we're going to need this other one for the power output from these drivers to our motors. So, and we'll see that once we get there. And I'm going to go ahead and stack this one on top of that. If I can get it under there. There we go. And you can actually turn this a little bit to get them a little flatter if you want, because there's enough wire here, I think. Whatever works for you. It allows you to get this done. That's really all you got to worry about. I'll go ahead and snug this down. And there we go. So we've got our first connections done. Now what I'm going to do is go over and loop this around here and get over here to the second connection. And remember, I'm going to have another one coming from over here like this. All right? Because we're going to keep feeding it over here, the next driver, next drive, next drive. So I'm going to go ahead and get this one started over here. Red again on L1. Blue. This is where it's going to get a little tighter because we're in between the drives now. Blue goes to L2. Again, this is a little fiddly to get these guys in here. They like to, these spade connectors like to grab on things where you don't want them to. I'm going to pull my ground wire out of the way for now, because I want to get my other red and blue wire in here. And how you flip these around can make it easier or harder when we do this. So you just have to look at the way the wires are running and the length of them and kind of judge for yourself which one's going to fit better. So I'm going to try to get my red one in here first. I'm going to pull these out of the loom a little bit here. So I'm going to go ahead and see if I can get the red one in on top of the other red. Sorry I'm blocking your view a little bit here, but like I said, this can be a little bit crazy to get these in here. Okay, there we go. Got the red in. Screw that down. Again, not too tight. You don't want to snap this stuff. You will regret the day you ever do that. Because I've done it before a long time ago. All right, so we got the blue in. Now I'm going to try to get the other blue in. On top of that one. And let's go underneath. There we go. Success. Now go ahead and tighten that one down. I usually give a little tug on them too when I'm done, just to make sure everything's good and tight and it's not going to come loose. So now I have my two grounds to put in, and they're going to go again on this ground over here, our earth ground. Stick that one under there. I'll come in and stick this guy on top of that one. And sometimes it helps to get your finger in here and push one down while you're trying to get this other one in. Might be blocking your view a little bit, but I think you guys get the idea what I'm trying to do here. There we go. I think it's in there now. So now, see if we can secure it. And again, I put my finger down on them just so they don't wiggle away when I'm tightening them down. All right, now those are good connections. Everything's tight. Again, you want to wiggle them, make sure nothing is moving, look straight down on it. Now see, I got a little bit of looseness in this red one, I can see that. So this is why we look down and check on it. And I got to tighten just a little bit more, keep that from happening. You want to make sure this stuff is tight. Because remember, this is a motion system. If it's not tight, you're going to have a problem somewhere. So you always go back and check this stuff and make sure they're good and tight. All right, so that's all there is to it. And I'll continue with my other pieces of wire here to go from here to here to here to here and end up down here on the last guy. So I'm going to go ahead and do that and get everything tightened down right. And when we come back, we'll see what all that looks like. As you can see, we have all the wiring done and all the servo drives are powered up. And this was not too hard to do. You just have to be patient with it, like I said before, and just, take your time and you can get it done. It seemed to be a little bit easier once I got going, just to do like the two red wires at once and don't worry about where the blue wires are, and then come in with the blue wires after that and then tighten them down. Just do one set at a time, in other words. So yeah, everything went pretty smoothly. You could actually spread these driver boxes out a little bit on these rails to get a little easier access if you wanted to. But it really wasn't that big of a deal. Of course, you don't want to put your finger on there. All that stuff's hot right now. But yeah, it's not a big deal to get in here, I think, and, work it. I didn't have too much trouble. And if you also see on here on these screens, they're all the same. They say AL09, which some of you guys who know servo drives will say, hey, that's an alarm. And yes, it is an alarm. And the reason it is in an alarm state right now is because currently I don't have any servos or actuators attached to the drivers. So this is an alarm indicating that it can't read the encoder. So it's basically an encoder alarm. It can't read it because it's not attached. But yeah, I think we're looking good here now, and we can go ahead and, call this done. Now we're going to hook up the output power from the servo drive to the servo motor. And this is, again, a very easy thing to do. It's easier than doing the daisy chain power that we did before. Each one of these cables is labeled, so it's going to make it pretty easy to get this right and not mess it up. We have, and I'll show you a little close up here of it. We have a brown wire with a U label. See, it says U. Let me get that around so you guys can see it straight up. It says U. Then we have a blue one that has a V on it, right there. And then we have a W on our black wire. Now we also have a ground wire here, the yellow-green, but we also have another black ground wire on here, and that's for the shielding that's in this cable. And we discussed the shielding in the cable before. So yeah, we have a nice shielded cable for our power here, which is an important consideration for fighting the EMI and RFI interference. Now on the block here, where we're going to use these compression fittings for the block, we have corresponding U, V, and W. So yeah, this is, I don't see how you can get this one wrong, unless you really try. So that's what we're going to do. We're just going to go ahead and put these on. So let's get to it. Get my U in here first. I've already got these loose, of course. So I just come back in and tighten them down. And the next one is V, so that's the blue wire. I'll put that in here. And get it tight, but don't get it too tight. And W, this is the black wire, goes into the last lug here. I have to loosen this one up a little. There we go. And one more, and that's our earth ground. And of course, that's going over to the last one. And I usually flip these around. These have the spade is on one side of this actual connector. So I usually flip them around so the lower part or the flat part right here is against the flat part or whatever I'm mounting it to. This to make sure I have as much contact surface engaged on this heatsink as possible for the ground, because grounds are very important to get right in electrical circuits. Got that one right, and there it is. Now another thing I forgot to tell you is you want to make sure you look on your label here on this cable, and make sure that you're hooking the right cable down here. I got a bunch of it right here in my hand. I'm just going to kind of stack them in here. And you want to make sure that you have the right cable. And this one says front left servo number 2. All right. And if my little label up here says front left servo 2, it's upside down, but that's what it says. So I know I'm hooking the right wiring section that I need. It's wiring bundle, if you will, to this. And then later on, we'll come in and just hook up our data cable once we're hooking up our servos themselves or our actuators. So there you have it. That's how easy it is. And then we can close our top. Now the top may not close all the way down because we've got this double stack over here, but that's okay as long as it's kind of laying down a little bit and out of the way. And you can do the same thing over here. That's all you're doing. It's good enough, because remember, we're going to have a box built around this whole thing. So, and of course, we're going to be running the cables out of that in certain ways of that box so we can hook them up to our servo motors. And of course, our mains cable can come out and get into our power strip over there. So again, we'll get to those pieces once we get there. So I'm going to finish wiring up the rest of these and make sure I get the cables in the right order on the right drivers going to the right servos. And when we come back, we'll take a look at that. Now you can see that I have the power output to the servo motors or the actuators all wired up now. And again, this is relatively easy. It was easier to do than doing the mains power, the loops that we put in. That was a little more fiddly, but this was just a straightforward screwing down connectors. Very easy to do. Just make sure that you keep your letters and your colors on your wires right. And always go back after I'm finished with the job and everything's tightened down just for a sanity check and look at it again to make sure that everything looks right. And you can see I have the Servo Drive boxes now already powered back up. And of course, we're still seeing the alarm, the AL-09, but again, we don't have any encoder attached to these drive boxes, so that's why that's there. So yeah, I think we can call this done and successful. So we've got our servo drivers all mounted, and we've got them cabled up with power, but no communication cable set up yet. And this is actually a good time to, if you want to test your driver boxes and make sure they're working right, the servo driver element of it, and our actuators themselves to make sure they're moving when we tell them to. And it's a really simple test we can do here. And all you have to do is, obviously we've wired the power, so I've plugged in my traction loss actuator to both the plugs, the power and the data, which is coming off the encoder on the back of the motor. And you can see there's a plug that I plugged into the first driver box, and I'll kind of zoom in a little bit here. See the plug there? All right, so I plugged that in so we can actually communicate with the encoder and make it move. So we'll go ahead and zoom the rest of the way into our menu up here. Now you want to go, I'm going to get closer here and show you this. This is the mode button. Then we have an up and down arrow and a set button. So I'm going to press the mode button, and I've already been messing with it obviously. So DN, and then what we're looking for is FN, but you also have a PN for parameters, and we'll talk about that later. And yeah, so let's go back to FN. And now that I'm in FN, the 0 is always blinking. I'm going to go up to the one that I want to use. So 0 is not what I want 2. So I'm going to go 1, 2, 1 up. So now that's what I want. So I go over to the set button now and hold that down for 2 seconds. And it'll change to J09. All right. So J09 is fine, but I want to get into actually being able to move my actuator. So I'm going to hold that set button one more time, 2 seconds. And you can see it's J09 with 2 dashes now. Right. So now we can actually take these up and down arrows and move our actuator. Now switch over to the actuator camera, and you can see that I'm going to move it to the left first. There we go. It's working fine. Back to the right. And it'll actually move throughout the whole range of motion this actuator is capable of. So yeah, pretty cool. And then we back out with the mod button twice, and we're back in function. And I'm going to zero that out, though you really don't have to. And then we can go back to parameters and the DN and function and just go cycle through again. So there you have it. We're actually able to test things before we get everything boxed up and all our cable management done, just to make sure that you don't want to have everything all mounted and you turn the switch on and then you got a problem with something somewhere. So this is just a procedural test as I'm moving forward with the build. Now I'm going to go over some parameter settings that we need to have on these servo drivers to properly function with the PT actuator servos. And you see I have all 6 of them online now, and they actually are showing, I'm going to zoom in a little bit here. You can see they're showing an alarm. All of them are except for the one on the end. They're an alarm 09. And the reason they're showing the alarm and the last one isn't, well, there's a plug in the data port for this last one. And this is for the rear right servo 4. And yeah, so that's got the plug in it, and the rest of them don't see anything from the encoder from a servo motor, so that's why they have the alarm message up there. No big deal, nothing to worry about, because once we have everything plugged in, all that goes away. So let's go ahead and get closer here, and I'm going to go over some parameters here that you want to check. Now, this should be done at the factory by the time you get your servo drivers from PT Actuator. But I just want to go over with you real quick so we can check them. And I'm also going to do a shot here of a document that I made that shows you all the settings and the parameter numbers, and you'll understand what that means in a minute. And of course, you can always just take a clip art or something like that, a screenshot, and save that so you can use it on yours. Right, so first thing, we have 4 buttons over here that command or actually make adjustments and settings. And the first one is mod, MOD, which really stands for mode. We have an up arrow button and a down arrow button. Then we have a set button over here. So what I'm going to do is hit the mod button till we get to parameter settings. And we'll go through a couple more. There's the DN, there's the FN for function, and here we are, parameter. And you can see it's flashing as 0. So it's asking me, which parameter do you want to look at? And the first one on our document is PN8. So I'm going to hold this up arrow down till we get to 8. There we are. So now we're at 8. I'll go over to the set button and hold that down for a second, and that 8 will go away, and that tells me that I'm now in that mode to see what's going on. I'm going to hold it down, and there it goes. So I'm at 300, all right? So that's the torque limit for counterclockwise motion, 300, and of course, that's what it should be. So that's good. I'm going to back out of that, hitting the mode button again, and you see I'm still on 8. So our next one is 9, and I'm going to go to that just by 1 arrow up. So I'm at 009 now. Same thing, hold the set button down for a second till the 9 goes away, and then check that parameter. And yeah, that looks good too. We're at negative 300, and that's the torque limit for counterclockwise of the motor turning. So all that looks good so far. We'll go ahead and back out. Our next number is 51. So I'm going to go down to 1 here, and then I'm going to go over. You hit the set button, and it'll move over a space. So I can move over to the second one. Then I'm going to go up to 5. So that's 51. Now I'm going to do the same thing we did before and just hold the set button down. And there we go. And there it is, 5,000. Now, it should be 3,000. So that's not good. So what we're going to do is I'm going to go over and change that. But I want to change the 5. I don't care about these other 3. And again, we're going to use the set button to move points over in the different frames of this actual display. So I'm going to hit set once, twice, 3 times. So now that I'm in that position of the digit, then I can go down to 3. 1, 2, 3, right? And then I'm going to hit set, hold it down. It goes away, and now it's 3,000. Now I'm going to check this by getting out of 51, or getting out of that the function, the actual parameter setting that we were in. And then I'm going to go hold this down again and check it. And there it is, 3,000. So that's what we want, 3,000. So we're good to go there. And again, just hit the mode button. And now we go into our next number, which is 98. So I'll take the 1 digit and go up to 9. A little bit too far. Come back down. There we go, 9. Actually, not 9. 9's on the other one, so that's 9. That's 8. So we go over again, hit the set button, go over to the 5, and then I'll take that up to 9. So now we're at 98. So I'll hold that down. And there it is, 20. And that's what we want, 20. So that one's good. That's the pulse multiplier. And again, we just go back to the mode button. And the next one's going to be 109. So I can go on this digit, I can go down 1. And the other one, I'm going to go, whoops, let me go to the other one first. So we're going to go, what is it, 109, okay. Go up to 9. Next digit's going to be 0. And it's already 109. Because when you go to 0, it already, I actually turned this to a 1 when I did that. So I'm going to hold that down again, see what we got, and it's at 1. And it should be 1. So our smoothing filter is set at 1, and just go on down the list like this. Very easy to do, but you want to check all these and make sure they're right before you get your servos connected to your controller box and everything, and then you fire everything up. Just want to make sure everything is like it should be. So yeah, it's pretty easy, and when you're done, just get back out, and of course I can cycle through function, the DN, the function, and the parameters again. And yeah, it doesn't matter anymore. And I'm actually going to turn them off. Let me turn this power off to it. And then I'll turn the power back on. And you can see I'm back to 0. And the one that I changed is one I'm interested in. I want to go back to 51. Go to PN, there it is. And I'm going to go back to 51. So I go 1, up for 1. And I'll go over the next digit, up to 5. And then I'm going to hold the set button down again for a second. And there it is, 3,000. So the setting did take effect. We're golden. We're good to go. So yeah, that's all there is to it. Just go down to the list that you see in my video here. If you did a screen capture or whatever, or just pause the video and just go down the list and make sure all these parameters are like they should be on the list. But they should be set up okay already from PT Actuator. But I've been playing around with mine. So anyway. Yeah, that's about it. See how easy it is to program these things or to set the parameters in them? It's pretty easy stuff, really. Now for a closer look at the PT Actuator controller board. Now, this is using a Thanos controller board that some of you may be familiar with if you're into the motion thing. And you can see this is the AMC-AASD all-in-one servo motion controller. And you can see we have 6 servo ports here, and we actually have another accessory one over here. So if you wanted to run something, another servo for whatever reasons, like a belt tension or something, then you can do that. So 7 total inputs for this. These are 25-pin connectors, and you'll see how we connect this up as we go along here in the review. And down here we have some buttons that we can push to actually manipulate the menus and so forth. We have a selection button here we can push, and also a dial that'll navigate through these things. We have a dip switch system over here. Right now the dip switch 1 is on, the rest are off, but you can actually turn that one off and turn the bottom one on and do some testing of the servos without having anything but a powered USB plug sitting on here. So that's very cool that we can actually test things while we're building our rigs, and yeah, without even hooking it up to the computer. So I really like this box because of all the features that it has in it. And we have a jumper here that we're going to use for different settings and different testing, whatever. We have a lug, electrical wire lug there, and that's for a kill switch if you want to mount your kill switch and just do it through here. And also, and I'm going to be doing something different, by the way. I'm going to be actually putting a plug on the end of this for my kill switch, which means I'm going to have to cut the case, but we'll cover that as we go along. And I'm going to go ahead and, let's see, on the back, let's show you the back here. It has these brackets here, and we take these brackets loose, and this is how it ships. And we'll flip them around so the ears, they're sticking out on each side, so we can actually mount this to our metal box that's going to be encasing our servo drives. And like I said, we'll get to all that as we move along. And anything else we want to see here? There's a USB 2 plug, and we have a power plug here, a DC power plug, but you don't need the DC power to run this box. It runs right off the USB power. So this is the interface between the servo drives and our PC. And it's really got a lot of features, though. This is a very powerful interface compared to some of the interfaces I've seen on motion systems, where basically it's just an interface to get all the signals converted to USB so you can plug it into your PC, and then let SimTools control everything from there. Even though this works kind of in conjunction with SimTools, I guess is the best way to look at it, but has its own features and filters running in hardware in here that are going to be quicker and more effective, I imagine, than just running all your filters and things through SimTools. But we'll see that once we get there. Anything else we want to see? Oh, let me go ahead and show you how this works. I happen to have a USB B plug sitting here, and then it's just stuck in the power outlet, and I don't have it on a computer anywhere. So we'll plug it in, and it powers it up. There we go. And you can see there's the screen that we're going to be using, and it shows 1, 2, 3, 4, 5, and that's the servos. If we want to do some testing, I could change some jumpers around here and do some testing of the servos. But we're just going to navigate through the menu here just to show you some of the options. Platform check. Let's see. Let me go back to there. It is. Number of actual motors. This is already set up at the factory for 6 axes. 6 axes rather. I can say axis, can't I? So we have 6 axes, and you can actually change this. And the menu is very easy to use. You use this button here to select. If I wanted to change that, I just push it. And then it, well, okay, maybe I held it down too long. There we go. So you can see my axis number of motors is 6 right now, and I can just actually adjust this. If I change the configuration, added something, I could put 7 on there. So yeah, very simple little menu navigation system to use. And then if you want to exit the menu, I don't want to change anything, obviously, because I still only have 6 axes. And then we can continue on to other settings. Platform checks, we can make that on if we want to. Different park position options. The standby power, let's see, stroke all. It's 100 millimeters now. So I'm thinking it's going to be more than that. Some of these things I'll probably have to set up. Lead screw. You can tell what kind of lead screw size or sizes in there. Which the lead screw would be the ball screw assembly. And tell them what it is. Directionals, inline. Ratios 1:1 because we don't have any belts or gears or anything in these servos or these actuators. So everything's 1:1. No fold back or anything. Pulse. We got pulse. We got function of kill switch. Park standby. Number 2 is park the motors if you hit the kill switch. Let's see. Button speed. Pin level. Let's get to the... Oh, here's the spike filter. Now, this is a filter that runs in hardware in this box here. Or on the Thanos board. And they're always updating the firmware and stuff and doing different things with that. So the spike filter is something that's going to be running in hardware in here. So if you get a big shot, like you crash or you wreck into a wall or something while you're driving your car, this spike filter will cut the peaks off so that you don't overtax the actuators on your system or throw yourself out of the seat. Right, so nice that we have spike filters and we can set that for different levels. And again, we'll get to these settings and stuff when we're actually have everything hooked up and we're running it. Let's see, this is the directory. What does that say? RC servo direction. Okay, so well, like I said, I'm not going to go in each one of these. Rotation offset is in degrees. Let's see, and there we go. That's what I really want to show you there this is the 2.10 version, and it's beta fix 6. And I just downloaded the beta fix 6 and loaded in. There's a little download or boot or loader, a firmware loader, if you will, software package that Thanos offers, and it was really simple to do. Just plugged it in the USB. It found it on Windows 10 right away, and I downloaded and then loaded into this box the Fix 6, which is the latest one, with a dynamic spike filter feature that's in the new firmware. And of course, Thanos is always updating that stuff themselves. Right, so pretty cool here what we have, I think, in this controller box. And again, I can't wait to get all this stuff running so we can see it. But yeah, of course, I'm going to take a peek inside and see what that Thanos board looks like in person. And I'm going to be actually cutting a hole in here so I can put my kill switch plug into this housing, which is not in here right now. But I'm going to do that, and I'll probably shoot some video and talk about it the way I did that. And I got to solder some wires onto the board. Not a big deal. There's directions for this on the Thanos website. Very easy to do. The hardest part is going to be cutting a square hole into this. So anyway, there we have it. The PT Actuator AMC AASD servo motor controller. Now we'll take a closer look at this controller board. And I've already taken the screws off the sides of the case here. There's 2 screws on each side, and they are little Phillips units, little teeny guys. And you can see I don't know how well you can see that, but they actually have blue Loctite on these screws for the controller box. So, when I'm doing reviews and I'm taking things apart and look at things, it's the little things like that, attention to detail, that get my attention. Because you didn't have to put blue Loctite on these screws if you didn't, just to hold this case together. But they do because they know that this is going to be in a motion system, so they're taking precautions. Now this top will come right off after you do that. Have to kind of hold stuff a little bit. It should come off. There we go. There's our top. And there is our board inside. And I am going to take this board out because I'm going to have to do this anyway because I'm putting a kill switch on here and I have to do some soldering. So there should be, I've already taken the screws out. There's 4 screws around the perimeter of this board. I've taken those out, some Phillips screws. And I'm going to gently see if I can get this to come out off of this. There's a little board in here. Let me show you what I'm talking about. Down in there. I don't know how you can see that. There it is. So I have to pull this off of there. It's actually the board that's supporting this 25-pin connector here. So I'm just going to kind of wiggle it back and forth, and it should come free, and there it is. Aha! And you can see that's how that connector's sitting in there with the little pins in there. And this little plug right here that's on the board goes in there. And on the bottom, we can see we have a daughter board underneath the main board, and it's also plugged in with these little pins in there. Pin plugs, as I call them. And we can see this is a Thanos board. Thanos. And let's see if there's a revision on this. LCD connector, I don't see. Yeah, you go the other way and look at it, you can see the revision number there is 1.3. All right, so on this board, I'm going to be soldering some things. And there's a video that Thanos has that lets you see what you need to do as far as soldering it. And I'm going to, let's see, I think it's over here is where I'm soldering it. It's not over here, is it? Let's see. Yes, it is over here. Had the wrong side. There we go. Steer you guys wrong. So here we have the kill switch connectors here, and we have an FS, I don't know how well you guys are going to see this, FSW and a KLM on those pins there. So I'll be soldering to that, and I'll be soldering to some of the pins over here. You see these little pads here? I'll be soldering some some wires into there for some LED functionality on this kill switch, and I'll show you what that looks like. Let me kind of set this here. Nothing gets messed up. Let's go ahead and just put it back in the right way. I need to keep it off because I'll be doing some work on this. And this is the kill switch I'm talking about. And this is a third-party kill switch. We'll talk a little bit more about that later when we're using it. And it's nice metal, aluminum type of kill switch there, and it's the usual switch. When we push it down, it'll kill the power to the system, and then we turn it clockwise, it pops back out. But this one actually has some LED indicator lights on it. So it can tell us certain conditions of the system while we're just take a glance at these lights here. I've never seen anything like that. And of course, as you can see, it's kind of like a stoplight. It's got the little hood on it and everything. It's a 3D printed unit. I don't see any places to actually mount it to anything, unless there's some holes back here. I guess you could mount it through there and then put it back together, you know, if you want to do that. I'm probably just going to put some Velcro on there and stick it on. But yeah, I like the little lights, and they're actually buttons too. You can push them, they go in, you push them, they come back out. So yeah, this is going to be kind of cool sitting on your rig if this is what you want, or you can go with a regular emergency stop. And I have one of those too. I'm not sure which one I'm going to be using. And I've already shown you in the parts, I think, this one. And this is a custom unit that Shao over at PT Actuator made for me. It's got the SRG logo on it. Nice heavy duty aluminum piece there, and of course the same kind of functionality for the stop. And on the bottom you can see there's not a lot of stuff going on there, just 3 pins. But this is a nice machine. Look at the machining there on this aluminum piece, and it's got some heft to it, because you can see here's where, see the lip there? It's solid aluminum from there to the top here, because you can see down there where those holes are, it's all solid aluminum there. So it's got some good heft to it. I'm going to try both of them and then figure out which one I like. But this is kind of nice, the custom stuff. Anyway, I'm going to have to put a plug in this while we're doing the look inside. I might as well show you this, because I'm not going to do a detailed video of me doing. I just might show you guys some video of me actually doing the soldering here and attaching this plug. This plug is going to go, it's over here, in the housing, and I'm going to cut another slot in the housing right here so that this plug will fit down in there. Like so, or maybe like this, right? And on the video that Thanos has, he put some double-side tape in there to kind of hold it still, but I'm also going to cut it so it fits down into these grooves here. The slot does that I cut, so it won't go anywhere if you pull on it, okay? And here's the wires that we're going to be using to solder this up with. All right, so we've got ground and green, blue, white, yellow, and red. So again, I'll probably just show you some quick B-roll of me actually doing the soldering on this, and then the result. And yeah, so I might as well, I think we've seen everything we need to see as far as the Thanos board. And you can buy these Thanos boards and do a 3D printed enclosure for these, that some guys do, for other motion systems that you can build out there. So yeah, it's a very versatile type of system on here. I really like this Thanos board. So without further ado, I'm going to go ahead and get on to cutting slots and soldering wires. I'm back with the slightly modified case now, and you can see I've got the RJ12 plug in there, and it wasn't too bad, just a matter of getting the old Dremel out and doing some cutting some straight sections first, and then coming down and cutting a horizontal crossing section to get everything, most of it out. It's kind of a rough cut, and then I came back in with a hand file and filed off all the rough edges and squared everything up properly so that this fit like it does now. And then it's a matter of getting the soldering iron out, and yeah, just go ahead and soldering these wires in the right order. Again, there's a video that shows you how to do this as far as the order in which pads you should be soldering to. And yeah, no big deal there. Everything worked out fine. And yeah, so now it's time to plug the USB back in, and we'll plug our switch in, our e-stop, and see what happens. So I'll plug this in first, and we'll go ahead and power this up. And plug it back in because it popped back out. There we go. Click that time. All right. Now I think we're good. So everything looks to be working on the controller. So I didn't mess anything up there. Yep, that looks good. We can still, let's see, we can still change things. Good. See if I can change my 6-axis. There we go. We can change 7 to 5. Okay, good. All right, get out of the menu. And now we have some LEDs on the kill switch. Now, well, this is showing up here. See, that yellow one's lit right now. The red one and the green one are not. And so if I press the yellow one, the red one comes on. And the red one is indicating it's in the stop mode, even though this is not pressed. I'm guessing that's what it is. I don't have the manual yet for this. But yeah, if I push the yellow, then the red goes on and off. If I just push the red one, nothing, the yellow starts flashing. Now, I've had this hooked up to an actuator, the controller, just to check it out. And it moves when I actually press the red in and out. And the yellow kind of just stayed. I guess the yellow must be in standby mode or something like that. But anyway, that's how it looks. So it's all working, and there is a 40 millimeter spacing this way and this way on the back of this housing. So all you have to do is take a screw out here and take another screw out. Let's see, get this back off. Take a screw out on the other side, and this shells come apart, and you can put your screws in and T-nuts in the channels of your profile and go ahead and hard mount it. So that's how I would be mounting this. All right, so easy enough. Project is completed. So I just want to show you guys how I did this in case you wanted to do that to your controller board. Now, I've talked to PT Actuator, and they are considering putting that in at a customer's request so that you won't have to do that. The port will come already ready to go, and you can pick up one of these e-stops. Anyway, so we'll go on to the next segment. So this system has a really nice set of aviation connectors for the servo motors. And there are tabs on the inside here, and one is wider than the others. And just want to make sure that you do line those tabs up, just kind of look straight down on it, and you can see which one is which. And yeah, then just slide it on. And then you have the screw collar here, and just kind of screw that on, holding them both together with 2 hands, get it started. Now, I actually like to push these together as I'm tightening it like this. So I keep pushing it as I'm tightening it. It makes it easier to turn that collar. And yeah, just keep doing that until it stops. Easy enough. Yeah, really nice high quality connector here. I really like this. Now I'm going to show you guys how to attach the data and communication cables. And first one we'll do is the communication cable, and that's the 25-pin DIN. And just want to make sure that you have the correct shape and the right orientation to plug this on. Very simple. Just kind of push it down there, and then we're going to start screwing these screws in, because obviously we want to screw these in so it stays attached, and because this is a motion system, there'll be vibrations. And sometimes these can be a little finicky to get started, these screws. But yeah, once you get them started, they go in pretty good. And I like to rotate back and forth, so I'm pulling the plug this way and that way down onto the connection and just kind of rotate. And it seems to go on better when you do that, because it keeps the plug from getting off angle and then the screw not getting a straight shot down on the threads that are in these little threaded pieces in here. So yeah, then give it a little jiggle, make sure she's nice and tight. And then we'll go over to the data plug, and this is the connection to the actual servo motor, the encoder on the servo motor, and that's how the driver communicates with that motor. So we just kind of do the same thing with this one. Now this has screws in it. These are little Phillips screws, and I just happen to have a Phillips screwdriver handy, and they're going to do the same thing. I'm just going to start back here and just kind of get this to start. As soon as I feel that starting and I see the plug start to move that way, then I'll come back over here on this side and start this one. And do just like I did before, kind of just rotate it back and forth to get it to go down completely on that plug. And you don't want to over torque this stuff, you just want to get it snug. And that'll do it right there. Give it a little tug, make sure everything's nice and tight, and there we have it. Here is the PT Actuator controller, and you can see I have all of the communication cables connected now on this. And I actually made some labels because they didn't come with it that will, you can actually see which number it is, just to keep things neat. And when I look at one of these plugs, I can tell immediately which servo it's going to, or servo driver it's going to. So also, the same way that you're going to do that we did the other plugs, you want to make sure that you get these plugs screwed all the way down, all right, on this connection, because you can get errors if you don't do it. So you got to make sure they're all the way down, and you can kind of just look down each side there and see that they're equal, and we have it screwed down. And again, these can be a little finicky, these kind of plugs, and you just have to take your time with them and just tighten them. I kind of rotate back and forth like you saw in the earlier pieces that I showed about making the connections. And just make sure you do a little bit on each side. It should be able to bring it down evenly to where you don't get a screw off angle, and then you can get into trouble with that real quick by stripping one of these out. And you certainly do not want to do that. But there it is. We're all connected to our controller now. And yeah, all we have to do is connect the USB power on it, and then we're going to do some testing on the system to make sure everything is working. Now we have all the cables connected, and we're going to do a startup sequence for the first time. And I just want to show you guys this so you can know what to expect and what to see. And you can see we have movement here. You can see the 4 main actuators have already gone to park, and the traction loss and the surge are actually calibrating now. And you'll see the surge go home first. You'll see it go in the other direction. So it's going home to its park position. So it parked, and the other one parked. So this is what we want to see. 6 Ps, and we're good to go. So yeah. That's the startup sequence after we have everything cabled. As you can see, I have a little test loop going here, and it's called a servo test. So I can make sure all the actuators are moving like they should be. And I'm also watching how much they go up as far as cable travel. So I know where I need to have the slack in the cables so nothing gets kinked up or pinched through the motions here. And of course, you can see my cable management is pretty much spaghetti Eddie at this point. But we're going to clean all that up and get it looking good. So I'll show you what it looks like on the controller here. And it just says servo test. Now, if you ever do this, you want to make sure that you set this controller up for travel being 140 millimeters, not 150. 150 is the actual travel of each one of these actuators, which means all the way to where it hits the stop, the ball screw, as far as where it's hitting the stops, as far as coming all the way out and then going all the way back in. And you do not want that going on in these actuators. You want some kind of a little bit of a buffer there on the end points so that we don't slam the stops every time that we extend all the way to the limits of the travel. And this is done in all actuators and all systems, because obviously we don't want the wear and tear on the ball screw and everything else in there. And it might have a premature failure. But anyway, you can see how cool this is as far as everything moving, and I can walk around and see what each one of these actuators is doing. And I can see, as far as you can see the cables moving there. Again, I can measure that and see exactly where I need to be as far as play for the cables. And then I'll do this again one more time to check. Once I do my cable management and get everything zip tied up where I want it to be, I'll do this one more time, and just to make sure that everything's working like it should and everything looks good. And also, again, this bracket that we have on the actuator for the traction loss, you can see how that rotates with the arc of the traction loss movement. That is very cool that it can do that. Keeps all the side binding pressure off of this actuator, because that bearing assembly allows it to move back and forth. Very cool. Yeah, it's just a well thought out system here. It is complex on the build as far as getting everything put together and up and running, but it's a very high quality build too. And if you take your time and watch this video, I think most anyone could probably do this if you're handy with tools. All right, so there we are with our initial startup test, and everything is looking good. Everything's working well. So now what I'm going to do is just get on with my cable management. And remember, we still have a metal enclosure we're going to be putting around these driver boxes, and the cables will be coming out from that too. So we'll get to those parts next. I'm building the enclosure around the driver boxes now, and that did require some recabling. I had to take some cables off and move things around a little bit and then reattach them. So this is, I'm doing a little sanity check now just to make sure everything is still working as it's supposed to, and I'm still getting indicators on my servo drives like I should when everything is moving. And again, you can look down and see that all these wires are running out the side of this box because it has those indentations. Let me show you what they look like. Little cutouts that accommodate all the wires. And the box sides themselves are just attached with the T-nuts that we've been using throughout this build. A little bit different. They're not T-nut studs, but they're T-nuts that actually go onto these M5 bolts. And I actually have some over here. Let you see what it looks like. So we put this little T-nut on top of this M5 bolt. You know, the little walk washer too. Right. So everything's working as it should. Now our PT Actuator controller box has been mounted. They have holes for this that you screw it with those screws and nuts on the sides. So you can see it sitting up here now like that. And I can get you a little shot of it underneath there. Oops, I went the wrong way. All right. So I can still do everything I need to on the box because it's on the outside. And again, it's securely mounted now, so everything's working like it should. And of course, we have some cable management still to do, or still to come. But we'll be using these wire ducts for that as much as possible. So yeah, everything's looking good now. Everything's coming together. And now what I'm going to do is put the top on and go ahead and secure this box because everything's working. And I'm not going to be doing any other cable management on the box. And the lid that goes on the top has an arch to it, so don't worry about these wires. It looks like they might be sitting up just a little bit too high when you look down this way. But the box top is going to clear all that because it has an arch on it. Plus I can rearrange it. Still, I've got some slack in there that I can still rearrange the wires a little bit as we go back and forth, just that as the traction loss keeps getting in my way. Okay, so we'll get this thing boxed up and then we'll test it again. So we've got the box completely installed now. All the screws are tight. We have the top on, obviously. And if you look along the top here, you can see that there are holes in it all the way across the top, and that's on either side. You see it over there. And that will allow a convection-like airflow go through this because we're not sealed underneath, so that colder air underneath will be able to rise up with the heat and come out of our bending holes. So no fans, which makes this a very quiet system. But yeah, not that big of a deal. You just have to have a little patience, get all your screws in, and yeah, it looks good. Everything's nice and solid. This is a very solid box. Once you do this, I really like how solid this is. Again, it's kind of like the theme with this build. It's just really engineered quite well. There's a few hiccups here and there, but you know, obviously nothing to take away from how good this system is probably going to be as far as solid feel when we're in it and using it. You're looking at what we call a wiring duct, all right? And you get 4 pieces of this with your kit. And obviously this is for cable management. It's very nice that they actually put this in the kit because it bolts right to our profiles, and then we can put our wires and cabling inside of this, and the wiring and cabling can actually come out of these little slots here. Now there's 2 ways to open this up. You can either just kind of press your thumb in your hand, like this palm right here, and I can compress these teeth and it'll come off. Or when you have the room like we do now, you can just slide this stuff off like this. And you're done. And you can see the fingers here, and they have this little groove on them that captures that top we just took off, so you can slide it on and off, or we can just pop it on and off. And these fingers are very flexible, so we can put cables through here. And yeah, it's just a great solution for managing any kind of cables. And the cables on these guys are kind of thick, but it shouldn't really matter. We should be able to get them through this without any problem. And also, they have cut these in a 45-degree angle, or mitered them, if you will, so that when they join up together, get this correct. Then we have nice 90-degree angles like this on the cockpit. So we have slots on the bottom here, and that's for mounting. And what I'm going to use to mount them are these little button M5 button screws here. They have an M3 hex, or a 3mm hex on top. That's what I'm trying to say. And I'm going to use a washer on them like this. Just put a washer on it just to enhance the clamping area when we're screwing this down. And we're going to use one of these T-nuts on the bottom. So just like we've been doing so far, nothing's really changing except the, the size of what we're using here. And this is going to go through the bottom like this. All right. And then we'll put our T-nut on the bottom. So we got our screw hanging loose. Just like that. And then we'll just line it up with the channels and then set the whole thing down in there and tighten it up. Now we don't want to tighten this up too much, because remember, this is just, thin plastic here. What we're really trying to do is just get it to stay put, and so that the cable will stay where it is and the cable can't move it. So it shouldn't take too much pressure to get this thing screwed on like that. Right? So we're going to go over to the base assembly and get these mounted and see what they look like. Our wire duct is now installed, and you can see I just used 3 of these screws all the way across. And it kind of dictated a little bit where I put a screw to where these holes in the bottom of it fell. And of course, we're going all the way around here. And yeah, you can see the 45s lined up really nicely. Come over here and look at these. Yeah, this really is going to be nice. We've got a lot of cable hanging here, although some of it's going to be taken up by the slack we're going to need for the movement of 6 inches or 150 millimeters on these actuators. But yeah, we're going to be able to tuck a lot of this cable excess into this, so that I really like that they included this system with the build. All right, so yeah, I think it's looking good. All right, so you can see the cables sitting in our wire ducts. I don't have the tops on all of it. I just put the top on in this part, just so you guys can see what it looks like once the top gets snapped back on. And all the rest of the cables, I'll tuck those in a little bit as I put the caps on. And everything's going to fit fine. Shouldn't be any issues on this as far as it working like it should. And you can see I've done a lot of cable management on the cables themselves. Put some zip ties everywhere. And this is the only bundle I really didn't have great options for dealing with. Everything else pretty much is going to fit in these wire ducts. And you can see how I have the connectors zip tied onto the actuators themselves, because they were hanging down by the feet. And this really wasn't any other way to do it, because it would have just been banging on the frame all the time, no matter what I did. But what you got to pay attention to is, see the slack that I have in these wires, or these cables? So throughout the motion here, there's plenty of room, and there's no binding, nothing's dragging on anything, everything's clear. You can see these wires move, they kind of move together. Of course, this, I got to tuck this other one in. This doesn't have zip ties all over it. But yeah, everything's doing exactly what it should do. And I'll go ahead and walk over to this side. And you can see we've got our cables that are on the controller. The zip ties on everything. I'm using a 90-degree USB plug for the clearance on the height there. Just didn't want to make, I wanted to make sure it just wasn't sticking straight up. No big deal. And we actually have some connectors in the duct right here for the, I believe this is for the traction loss, yeah. Pretty cool the way this stuff works. And it'll actually take more cable than you would think. So anyway, all the cable is clear. Everything's working like it should. No binding anywhere. We've got plenty of slack on the 4 main actuators. So this is looking real good. And we're just about done with this. I'm going to pop the caps on these looms, or rather these wire ducts. And we're going to be built. We're going to be done with all this stuff. So yeah, very clever the way everything went together. And yeah, it's looking good. Final thoughts on getting the electronics, wiring, cabling, and basic system parameters set up for the PT Actuator 5DOF motion system. This is part 2 of a 3-part review I'm doing on this system. In part 1, I did the motion system build video. The PT Actuator 5DOF system uses the AASD 15A servo drives. They are a commonly used driver solution for driving actuator servo motors. They were easy to install, and setting up the required parameters for driving the PT actuator servos was really not very difficult. The cabling and wiring used in this kit was very well sorted. Once you begin the process of connecting the power cables and the wiring, it was really just a matter of repeating the hookups as you went along. Now, all the wiring and cable terminations and connections were well done with nice attention to detail, I think. And I especially liked the aviation style power and data connections that run between the servo motors and the servo drives. Another great plus is that PT Actuator actually uses a grounded shielding solution on the power cables for their servo motors. This will help mitigate any EMI, RFI interference that can be an issue with so many electronic motors and circuit boards running in close proximity to each other. And this is not the only example of PT Actuator doing their part to prevent this. They have made a solid metal enclosure for the servo drives themselves that again help shield the rest of your cockpit's electronics from EMI RFI interference, while at the same time giving the servo drives themselves protection and ventilation to keep them cool and out of harm's way. The PT Actuator AASD15A controller is a nice compact unit, using the Thanos controller board for its PC interface. Now, this board has a good feature set in it, like spike filtering and onboard actuator control abilities that can be used without being hooked up to a PC. It is easily mounted to the Servo Drive enclosure, so you will still have access to all of its features once all the cable routing and management are complete. Speaking of which, it's nice that PT Actuator thought also adding to the design in this kit the wiring duct included here, making cable management a lot easier than it would have been without it. I think PT Actuator has done their homework and come up with a good electronics and wiring solution to complement what I have seen so far as far as this system goes, which is pretty good stuff. They have made something that could be very difficult to figure out and construct much easier for the average person to do. Again, this is part 2 of a 3-part review series of the PT 5DOF motion system. In part 3, we will be setting up the software components and, of course, doing some real-time tuning and driving. I'm Barry Rowland. Thanks again for watching the Sim Racing Garage channel. Don't forget to hit the subscribe button, and if you would like to help support what I do here at the SRG, visit my website at simracinggarage.com.